Alright, let's look at 2.4 number 3, which we may or may not have done before.
Wait, what is this chapter about?
Good question.
Oh, you've done it before.
So, failing the I don't know what to do with this, I'm gonna try variation of parameters, right? Like, try the one thing you're good at. Might work. Alright, so, first things first.
No, not even that.
I'm gonna multiply through by 1 over x squared.
Okay, yep, did that.
Okay, so I got y prime plus 2 over x squared. Y is 2 over x squared e to the 1 over x, y to the 1/2 power.
Yep.
Okay, cool. Then I'm going to try the homogeneous version.
Oh, over x.
So y homogeneous prime plus 2 over x squared y homogeneous is 0.
Yeah.
So y homogeneous is e to the minus integral of 2 over x squared dx.
Okay, yeah, I got that.
Okay. So y homogeneous is e to the...
It's negative 2 over x is the integral of it.
Close.
So then,
oh,
they
okay.
cancel
So
out.
the integral is negative 2 over x,
Right.
and you have a negative sign, so you got e to the 2 over x.
Right.
Yeah.
And you're like...
Right.
Okay, so then you're like, alright, so then I'm guessing, right? Really, I'm trying to run variation of parameters. So I'm saying, alright, so let me try y equals u e to the 2 over x.
Oh yeah.
And then you're like, okay, so y prime then is u prime e to the 2 over x plus u e to the 2 over x, and then I need the
Prime.
derivative of the inside, right?
No, what were
So the derivative of 2 over x,
natural log 2?
The derivative.
Wait.
Derivative.
You're right, you're right. Negative.
Integral, homie.
More negative.
so I think I got a bring the power down, that's a negative 1,
Yeah.
and then x to the 1 lower power,
Yeah.
with the numbers still kicking around. Is that the problem?
Yeah.
Is that where you guys got dark?
Could have been.
Maybe.
We'll find out sooner or later.
Okay, so then you take this and plug it back in, right, to here. So I got u prime e to the 2 over x plus, oops, minus, I suppose, minus 2u over x squared e to the 2 over x. And then I have a plus 2 over x squared times y, which is u e to the 2 over x. And that's supposed to equal this chunk. So 2 over x squared e to the 1 over x, y to the, and this is the part I always screwed up, right?
Oh,
It's not a y, it's
damn
a,
it. It's the other stuff. I think so.
it's what the u it's what y
no,
is,
Wait,
right?
no, I fix it later. Never mind.
So y was u
Oh, yeah.
e to the 2 over x, and then you have a to the 1/2 power on that. And then you're like, okay, so let's see, I get to cancel some stuff at least. So those two cancel per usual. And so I'm left with a u prime e to the 2 over x is 2 over x squared e to the 1 over x u to the 1/2 power.
Just multiply, yeah?
Yeah, you basically need to distribute that power in there,
Wait.
and then an e to the 1 over x.
Yeah. Oh, wait.
So that's a e to the...
Yeah. Alright, and then you do the set bars.
Okay, and then you need to separate your variables. And really you have here an e to the 2 over x on this side, and you also have an e to the 2 over x on this side.
Hey, hacky slashy.
So multiply through by 1 over e to
damn.
the 2 over x.
That's what we were stuck at right there.
Hold on. Wait.
Exponent rules for the
How did
losers.
we get from that step to the loop? To the
No,
next
we
step.
were there.
This?
But what we also had, we had everything over x squared. Like back from the start.
That's a problem. Oh, right.
You had everything over x?
Even the e and y.
Yeah,
The
that's
U
fine.
prime.
No,
That's,
but how did you go from that step to down step?
okay, so here I have something like a times b to the n, right? So I said, alright, so that's a to the n times b to the n.
Okay.
Right, so I got this guy to that, and I'm like, okay, so that's e to the 2 over x to the 1/2 power.
Yeah, so you multiply those.
Yeah, so you're like, alright, so that's e to the 2 over 2x.
And then you
Split them apart.
Yeah, you can cancel some 2's.
Damn.
And then here I'm adding the powers, so 1 over x plus 1 over x is 2 over x.
That's what it was.
So you got a u prime is 2 over x squared times u to the 1/2.
Good thing it's separable.
Yeah. I mean, it's supposed to be separable, right? Like, that's the idea of variation of parameters for Bernoulli. Basically, it says, look, even if it's nonlinear, as long as it's nice enough, you can hit it with variation of parameters, and it won't solve it right away, it'll get to something separable.
You see, that did throw me when we did this chapter, because I couldn't remember what separation of variables was, because I knew it couldn't have been Bernoulli's. But they're the same thing.
Bernoulli's always ends up in separation of variables.
But they're still the same thing. You just have an extra step.
Okay, yeah. That's fair. Alright, so then separating variables, what do you get? I think you get
Oh, integral of things.
the integral of u to the minus 1/2 du is the integral of 2 over x squared dx.
Oh, drop it, pop it, 1/2, right? Over
Yeah,
2,
so-
2.
U to the 1 higher power divided by the 1 higher power is, and then this crap is 2x to the minus 2, right? So pop the 2, x to the 1 higher power over the 1 higher power at a constant. And then there's actually something just a little bit subtle here. So you need to multiply both sides through by 1/2, right? To clear the 1/2 in the bottom there. So you get u to the 1/2 power equals minus 1 over x plus a constant. And then you're like, okay, so square both sides, right?
Yes. Of course.
Is with that. Keep in mind, right, that when you go to solve for a constant here, right, if you had an initial value,
Oh, the constant has to be slapped inside.
you're going to get some kind of equation, right, where you're going to take the square root of something. There's a plus or a minus required when you do that.
Yeah.
That feels like it violates existence and uniqueness. Does that make sense? Because you'd get 2 answers.
Right.
You'd be like, what the fuck?
So that's unique in 2 places.
Yeah, you're like, so I understood unique to be that there was only one.
Well,
Not-
not always.
So the issue is that here, in order for me to take the square root of u, right, u itself has to be positive. You see that? So if the c you get is going to allow this to be negative, then it's not a valid c. So the existence and uniqueness theorem doesn't say anything about variation of parameters as a technique. It doesn't say there exists a solution that's unique and you'll get that by doing variation of parameters. Right? Variation of parameters can sometimes yield a couple of options and you have to use your brain to pick which one it is. Kind of make sense? So ultimately here you should get y is e to the 2 over x times this thing, c minus 1 over x squared. Cool?
Yeah, definitely could have done that by myself.
Is that your
We just-
exponents for the
right.
problem?
Yeah, right there.
Yeah, exponent rules take some, like, you gotta remember
used
those
to.
things, and you gotta be, you have to be precise with them, right? You don't have to be fast, but you do have to be precise.
Yeah.